that up. The 4 to 5 to 6 is the ratio of A to B to C. That you know. So, and then 24,750. The 24,750 is the what? Is it A's or B's or C's? It's the total, isn't it? The 24,750 is the total. So do you realize we need to get the total involved, don't we? So it's kind of like, you could always make the fraction bar thing. You don't have to, but I think it might be helpful. Just to see the big picture, you know what I mean? There's 1, 2, 3, 4 parts. So this is like person A, okay? And then next come 5 parts. 1, 2, 3, 4, 5 parts. This is person B. And then C is 6 parts. So 1, 2, 3, 4, 5, 6. Let's kind of erase the rest here. So that is person C. Yeah, so there's like 4 parts for A and 5 parts for B. And C has 6 parts. So the whole, what is it, 24,750. The 24,750 is going to be broken up among A, B, and C like that, huh? According to that fraction bar. Is that helpful just to see it like that? I think seeing stuff helps me anyway. So, okay, so how do we figure out like how much person A gets? What are we going to do? What portion? What part of, portion means part of the whole, right? So we want to take part over whole. So what portion, whenever we talk about a portion, we mean a part of the whole. Like if I said, hey, I'm hoping that 10 out of 36 people get A's in this class. That would be the part of the whole, right? 10 people out of 36 people. So that, and we could turn that into a percentage or a decimal or any kind of thing, right? So that's what we're talking about. Whenever we're talking about a decimal or ratio, it's always a part of the whole. So for person A, what part of the whole is theirs? How would we figure that out?
4 over 15.
Yeah. And how you get the 15 on that? Yeah, add them all up. Jesus? Yeah, good. Jesus is right on the money. We've got to add them all up. So if you add up, 4, what is this? 4 plus 5 plus 6, that's 15 total. Yeah, so there's 15 total sections. That's the whole amount. That's the denominator, right? Whenever you do a portion or a part of, like if I said 10 out of 36 people are going to get A's in this class, the bottom is the whole class, the whole fraction bar. And the part for A is 4/15 of the whole thing, huh? Okay, so that's their portion. That's their part. What do we do now to figure out their money? How much money does person A get? 24,750 is the total profit that they're going to divide among their ratios. So what do?
It would be for their part, so that's X over the whole thing was 24,750.
Yeah, well, we could do something with an X, or we could just say, look, shouldn't they get 4/15 of the money? Wouldn't you agree with that first off? Person A should get 4/15 of the money because they're 4/15 of the investment team, right? And what does of always become in math? Times. You aware of that? So it's just going to be 4/15 times the money. 24,750. I could do that in my head for you, but I hate to show off. So I'll let you tell me what the calculator says. Somebody got a number there? 6,600? All right, thank you. $6,600. That's person A's. That making sense? Right? Because 4/15 is their part of the whole. Right? So we just take 4/15 of the whole amount. That'd be kind of like if I said, hey, 20% of our class is going to get A's. Hopefully more than that. Let's say 30%. 30% of our class is going to get A's in the end. So how would I figure out how many people? Well, how big is our class? 36 people. So it'd be 30% of times 36 people. You would just work out that math. It'd be like 10, whatever that would be. I don't know. But is that good? Does that make sense? Of means times. So now, so that's person A. Let's find person B. So how do we figure out how much person B? What's person B's portion? They're part of the whole. They are 5/15 of the 24,750, aren't they? So that one's I can do that one in my head. 8,250. Because that's 1/3. How I'm doing that is I'm just saying, look, that's 1/3, right? 1/3 of 24,000 is 8,000. 1/3 of 750 is 250. You don't care, whatever. All right. So I just hit the buttons on the calculator. So then part C is same thing, right? Part C is 6/15 of the whole. Part C is 6/15 of the whole times the whole, right? Of means times. Part C is 6/15 of the whole amount. That one I can't do. I need you to tell me. What is it? 9,900. Thank you. There it is. And we're good. Are we good? Are we extremely good on that one? Anything I can answer on that? So you can just lay out a fraction bar. So number 8 here. Vonna, what did Vonna do? 36 goals. Scored 36 goals in her practice thing. Okay. Her success to failure rate was 9 to 8. How'd they write that? Success to failure. Success to failure rate was 9:8. How many times goal attempted? Write out the fraction. I always think it's helpful to see it. You know, if it was my test, my grade on the line, I would want to see the bar just for extra clarity. Okay, so 9 to 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, maybe I'm going to run out of room here. And then 1, 2, 3, 4, 5, 6. Yeah, a little bit. 7, 8. I guess right to there. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8. And then don't just write that, but also be super clear what those are. What are those? Well, this is success, right? Because this is her success to failure is 9 to 8, huh? So she succeeded 9 times for every 8 times she failed. Right, so you get what that means, right? Every 9 times she kicked the ball in the goal, for every 9 in, there were 8 that she tried and missed, right? Failed. Okay, so there's the fraction bar. So the question, what they're telling me then, from there, is that she scored 36 goals. How many did she attempt? What do y'all think? Any ideas? What do they want from us in the end? If the answer is 12 or whatever, 12 what? What do they want in the end? How many she attempted. So that's different than success or failure. That's success plus failure, isn't it? Attempted. You with me? So somehow we have to get attempted into the problem, don't we? Right? Number that she tried. You with me on that? Remember how I wrote out before? It's a good idea to write down the units that you are aiming at, the units that you want to get in the end, huh? So now, how do you do that exactly? Well, you could put success over attempted, Now how am I coming up with that? Why am I doing that? Well, I know I got to have attempted in there because that's what they want in the end, huh? So I've got to get attempted in there somehow because it's what they want from me, right? So how about success over attempted? I could do failure over attempted, but that it makes sense to do success also because they told me how many goals she got, which is how much success, right? All right, so here we go. Success to attempted. I'm going to put two equal fractions. What's it going to be? Do I do 9 to 8? Is that success to attempted? No, that's success to failure. So what's success to attempted?
17.
Yeah, does everybody see that? Right? Because if she makes 9 and misses 8, how many did she attempt? 9 plus 8, 17. So in other words, her success to attempted is 9 to 17. She makes 9 out of every 17 she tries. She attempts. Does that make sense? 9 to 17. And then from there, what am I going to do with the 36? Where's that one go? That's the goals she succeeded at. That's the goals she made. And then X goes down here, right? We always have an X. That's what they want from us, how many she attempted total. So she makes 9 out of every 17 she tries. If she made 36 total, how many did she try total? Does everybody see that? Is that making sense? And now, how do we solve that thing? Yeah, cross multiplied, right? We have fractions, so 9 times x is 17 times 36. I need your help again. What's 17 times 36? 612, okay. And then last step to solve for x? Yeah, divide by that 9. 68, huh? So 68 is the number she attempted. And there we go. How are we doing? We good? So the whole trick, let me go over it one more time. The whole trick is making sure that you have in your fraction setup what they're aiming for. They want attempted, don't they? They want attempted. So I had to get that. I didn't just come down and write success over failure, even though that's what they gave me. Because what's most important is what you want in the end. The goal, right? You want attempted. So I had to get the attempted in there, success over attempted, and I was able to get that because it's 9 out of 17. Just add those up. It's a lot like the last problem where we had the total. In the last one we had the total on the bottom somewhere. Here it is, right? We had the whole amount or the total. Because why? Because they were giving me the whole profit. So do you see how that works? If they give you the whole amount, then you've got to get the whole amount in the bottom of your fraction. And the 4, 5, 6, that was just the individuals. That wasn't the whole. Same thing here. The 9, 8 was just success, failure. It wasn't all attempted. Is that good? How many got that answer? I see a show of hands. I know. Only a couple? Okay. That's good. I'm talking about it for a while. All right. Let's keep number 9. Here, I can write it bigger for you. Number 9 says, large aircraft, 286 feet long. The large aircraft is probably 200 feet long, wingspan 229. Okay. So an aircraft, 286 feet long, wingspan, whatever it said. Oh, 286, 229. 286, 229 feet, right? Yeah. Scale model, 37, okay. A model of the thing, a little bitty model. Scale model, it's 37 centimeters long. So a scale model is 37 centimeters long. Probably want to know how long the wingspan is. Yeah. And what is the wingspan for the model? All right. So what do they mean when they say something is a scale model? Not just a model, but a scale model.
It's the same dimensions if they were going up.
Exactly. Yeah, so like a shrunk down version of the same thing, right? It's like what you do with a photocopier when you blow something up or shrink it down, right? All the ratios are the same, right? So in other words, if the wing is longer than, if the plane is longer than its wingspan, in the real thing, it'll be the same in the model, etc. All the ratios will be the same. So basically, the model is exactly like the real one. It's just everything's been shrunk down. All right, so how are we going to do this one? This is probably pretty easy for you, right? We can just do, there's a couple ways you can do it. You can do length over wingspan. Probably easy way. 286 feet long. So notice how I always write down the units. You don't have to, but I think it might be helpful to you. Kind of just keeps you on track. So length over wingspan for the plane, and length over wingspan. What's that going to be? That's my x, huh? For the model. Then just cross multiply and solve. Yeah, Giselle. Yeah, well, automatically, this is feet over feet, and this is centimeters over centimeters. So by default, it will just come out centimeters for us. Yeah. It'll automatically be centimeters on that. So, you just go diagonal like that. 286 times x is 37 times 229. That good? If you're, Giselle's question is good. If you're wanting a little more, I felt like I gave kind of a short answer on that. Let me show you specific. I don't know if you know, but units do things just like numbers do. That's how I survived physics. It was watching the units. Before physics, I didn't like units. They kind of bugged me. And then kind of wish they weren't there in problems. But then when I got to physics and I read these crazy hard word problems, I couldn't tell what was going on. I noticed if I just watched the units, a lot of times I would figure out what to do from the units. So units became a little bit more of my friend. So watch the units here. 286 feet, x centimeters. I've just grabbed 286 feet, x centimeters. This is 37 centimeters. This is 229 feet. Well, suppose I don't know what x is. Let me leave them off. I told you x is going to be centimeters. But let's suppose we don't know. Do you see what's going to happen next? My next step to solve this thing is going to be to divide by the 286 feet, isn't it? 286 feet. What will happen then? Feet will cancel feet. What units are left? Centimeters. See how x will be centimeters? You don't have to write all that in, but I'm just giving doubly clear reasons that it will be centimeters in the end. It'll be the same as what was above it. All right, so then you can just hit the buttons on your calculator. Whatever 37 times 229 divided by 286 is, like 30 about. 29, 30, 31. Somebody got it?
It's about 30.
What do you got? 29.6. 6 what? 63. Yeah, how far do they want me to go there? It says nearest whole number. Oh, okay. So so we'd round that to what? 30, yeah. Nearest whole number, 30. Good? And the units would be centimeters. Yeah, they're asking us for the units too. Good. All's well? Is that good? So the next few are going to be just like that. That one's easier because you don't have to worry about the total. It's just individual, all the way through. Okay, so there you go. Try that one. Give you a second to work on that. We could draw it out if you want. You don't have to. How about we do that? You can always do that if it helps. So oblong tables to round 7 to 3. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And that would be, what is that? Oblong. So the oblong tables. And then the other 1, 2, 3 are the round ones. So there's the fraction bar, they call that. They have kids work with these. These are just fraction strips or fraction bars. So, all right, so the ratio of oblong tables to round, 7 to 3. And they say the total number of tables is 60. How many of each? What should I do? What kind of fraction should I set up? What's the 60? Is that oblong? Is it round? It's total. So we got to get total in there, don't we? Because they're giving me total. See how I know that? So if they give you the total, you've got to get total into the problem. So I could go like, what could I do? I could do oblong. There's a couple things. You could do oblong over total, or you could do round over total. Doesn't matter, but you got to get total in there. Why? Why do I know that? Because the 60 is total. See how I'm aware of that? Okay, so let's go oblong over total. So according to the fraction bar, first off, we're going to do, two equal fractions. Oops, what's that? We're going to do two equal fractions. So, all right. So according to the fraction bar, what is oblong to total? 7 oblong to how many total? 10, right? This is 7 plus 3, 10 total sections in the fraction bar, right? 10's the total. So 7 out of every 10 are oblong tables. Where's the 60 go? The bottom, because I happen to put total on the bottom. 60 goes on the bottom. So then the top over there is my x. Cross multiply. And when I'm done, and notice that x is on the top, so it'll be oblong when I get it, right? That's why I write down the units, so I know what it is I'm finding and what I'm plugging in. See how I write down the units? Just to make sure I know where everything is and what everything is as I do the problem. So cross multiply, 7 times 60 is 10 times x. That's 420 is 10x. Bring it up here. Is that a little music for our Friday afternoon there? All right. And last step, just divide by the 10. 42, huh? So 42 oblong. Remember, x is oblong because x was on the top and oblong was on the top. So 42 oblong tables. They're going to ask us for how many of each. So they want to know how many oblong and how many round. How am I going to find out how many round tables? Yeah, I think, just subtract from 60 would be the easiest way, right? Because we know there's 60 total. Right? So I would just come up here and go, oh, okay, well, there's 60 total tables and 42 of them, 60 total. 42 are oblong. What's that? 18 are round. You could have done another ratio, though. Could have done that, too. We good? Is that making sense? Do you see how when they bring in total, then we've got to bring in total? See on number 12, right? The 60 is the total. Let's look back and compare. A lot of how you learn homework and get ready for a test is by comparing the differences and learning to identify the subtle differences from problem to problem. Look at 19. See how on 19 they never gave us total. It was just, how long, wingspan. How long, wingspan. So that was just length and wingspan. I didn't need a total, right? Whereas back here on number 8, it was 36 goals, success to failure, attempted. That's total, isn't it? That's a way of saying total. Because how many you attempted, that includes those you made and those you failed. Success and failure. So they were using total. So you got to watch out on these if they're using total or not. If they are, then you need to. Right? That's why I did attempted at the bottom here. And same thing here, I had to do total at the bottom. We good with that? So let's look at